Hello, my name is Mark Cartwright, and let me welcome you to NCCTI. This is just an introduction to sizing conductors. This presentation is based on the 2017 NEC. I encourage everyone to obtain their own electrical code book. It takes time and practice to understand and navigate the NEC code book. When you're watching my video, please follow along with your own code book. Very important. Okay, let's turn to table 310.15B16. I'm going to refer to this as table 16 from here on because it just takes too long. It's a very important table and most often used, and improperly sized conductors are a major hazard. Problem here is to learn that more than one section and chapter in NEC must be consulted before arriving at the correct ampacity. When using table 16, selecting the correct size conductor, some of the factors that must be considered is temperature ratings of the conductor, termination ratings. Take a look if you get a chance at 110.14C, type of conductors, that'll be in table 16, connected load, continuous and non-continuous load. Take a look at 210.19A, ambient temperature. You got two tables here. 310.15B, 2A, and B, and then the number of current carrying conductors, table 310.15B, 3A. Hopefully you got your code book turned to table 16 here. Of course, I got an abbreviated one. That's why I need you to follow along with your own code book. A good place to start trying to understand is the table 16 is the title block. Notice it's rated including up to 2,000 volts, 60-degree conductors through 90, not more than 3 current carrying conductors in a raceway. Cable or earth buried based on ambient temperature of 30 degrees, 86 degrees Fahrenheit. Ampacities for conductors rated 0 to 2,000 volts are specified in ampacity tables, table 310.15B16 through table 310.15B21. So you can see you're going to be using the title block to figure out which correct table to use. Very important. So let's take a look at table 310.104A. And let's look for the THHN conductor in this table. This table provides a lot of useful information about the conductor THHN. For instance, you can install this in dry and damp locations, which means like you can install this on a whip for an outdoor heat pump. So THHN maximum operating temperature is 90 degrees C. Okay, going back to table 16, it's showing that THHN would be found in the 90 degree C column. So for number 2, copper AWG, THHN would equal 130 amps. Using this table, it's easy to get messed up. Make sure that you're using the copper or the aluminum copper clad side. Other than the particular temperature rating of the conductor, there are other factors that must be taken into account before you come up with the correct temperature column. This is a good time to look at section 110.14C. Please read the whole section, take your time, try to understand it, and I'll explain more in the following slides. Whether it be the conductor temperature rating or the termination temperature rating, the lowest temperature rating of either sets the stage for the whole circuit. For example, we already know that THHN is rated at 90 degrees C. The equipment termination is rated at 75 degrees C, and the disconnect is rated at 60. The weakest link is 60 degrees centigrade. The 60 degree column will be used to determine the ampacity of this circuit. So a number 2 THHN would be rated at 95 amps. The 90 degree column is almost never used except for derating conductors, which we'll cover later. Looking at the bottom of table 16, you'll see a double asterisk that says refer to 240.4D. This is sometimes referred to as a small conductor rule. So let's find 240.4D in your code book. What this double asterisk is saying is when you're sizing 14, 12, and 10 AWG conductors, please note that the overcurrent device may be rated less than the maximum ampacity of the conductor. For example, looking at table 16 in your code book, a THW number 12 AWG copper conductor is rated 25 amps in the 75 degree column. That double asterisk footnote, which refers you to section 240 10.4D changes the ampacity allowed. For the most part, 20 amps is the maximum amperage for a number 12 copper wire. But you might want to look and take a glance at table 244G. There are a few exceptions. Hopefully you have a good foundation on how to use table 310.15b16. In the following tutorials we will build on that foundation. Thanks for watching and I hope it helped. You can email me at nccti@protonmail.com if you have any questions. Thanks again.